Good afternoon, everybody, and welcome to the fifth session of the summer term 2026 of SunoikisisDC Digital Classics. This term, as you know, is dedicated to exploring digital scholarly editions in classic, Byzantine, and medieval studies. Today's session will be dealing with Wikidata queries for Greek and Latin philology, and our speakers today are Camillo Pellizzari and our very own Monica Berti. And as always, if you're watching live, that is on May 19th, 2026, feel free to write in the live comment section of the YouTube video. And do tell us where you're watching from and ask questions or leave comments that our speakers will address at the end of the session. And as I always say every time, and it's never a lie, as you know very well, we have a lot to cover and way too little time. So I would like to invite our speakers to take the mic. So Camillo and Monica, please go ahead. The floor is yours.
Thanks. So I go on my presentation. Thanks for inviting me. And so, Wikidata queries for Greek and Latin philology. This presentation will be divided into three parts. The first two are by me, and the third one is by Monica. So in the first one, I will briefly introduce Wikidata and the Wikidata query service. Then I will go on speaking about the Pauli Visova, why it is important, also something about the Pauli Visova transcription in Wikisource, and how to query things around Pauli Visova in Wikidata, and then I will leave to Monica for LAGL. So, Wikidata and the Wikidata query service. Wikidata is a knowledge graph that has been created in 2012 as part of the Wikimedia projects to support Wikipedia, of course, but also with a lot of aims beyond this. So Wikidata is one of the Wikimedia projects. As you can see in this image, which is up to date. The last update was in 2023 with the addition of this project, Wikifunctions, that aims to collect pieces of code like JavaScript, Python that can be reused in other contexts to construct more complex programs. But all started with Wikipedia in 2001. And Wikipedia is an encyclopedia, but there are a lot of interesting things that you can do that are not an encyclopedia, but are still useful, also as support to Wikipedia, for example, collecting multimedia files, images, videos, spreadsheets, and so on. These are mainly on Wikimedia Commons, the project that you see to the left of Wikipedia, and that supports all these other projects. And below Wikimedia Commons, you see Wikisource, where there are the transcriptions of public domain texts or texts that are not yet in public domain, but have been freely licensed by their authors. And this is, of course, relevant for the Pauli Visova. And then you see here below Wikidata for structured data. So Wikidata is a very big project that has, as of now, data about 120 million items. And these data are stored mainly through statements, and the predicates of these statements are more than 13,000 properties. These properties are in part used to store factual data about these entities. So, for example, the date of birth of a person or the number of inhabitants of a city and so on. But they're also used to store the correspondences between a Wikidata item and, for example, an article about this same person in an online encyclopedia, or the authority record for this person in a catalog of a library, and so on. So Wikidata is huge. It describes everything that is present in at least one Wikipedia, but also a lot of things that are not present in any Wikipedia, but are still considered notable. And it receives every day more than 300,000 edits by humans and by bots. And the humans that edit Wikidata every month are more than 20,000, as you can see. And if you want more complete statistics, you can go to Wikiscan, and there is everything that you can desire about Wikidata and the numbers of the content of Wikidata and of the people that edit Wikidata. So the data in Wikidata, the structured data in Wikidata, are released in CC0. If you think about Wikipedia, the data in Wikipedia are not in CC0. So if you have a Wikipedia article and you want to reuse it, you have to respect its license that is CC by SA. So Creative Commons attribution share alike. This means that if you want to reuse an article in Wikipedia, you have to cite the source, which is Wikipedia, and you have to use the same license. So Creative Commons attribution share alike. For Wikidata, CC0 means public domain. So you have no restrictions in the use that you can make of the data stored in Wikidata. And this also means that the data that are from Wikidata go to a lot of places, and we are not really sure about how many of them and which of them, because in fact, most of the data reusers of Wikidata don't mention Wikidata. So its importance is also far bigger than most of the public knows. Wikidata is not among the most visited websites in the world. Wikipedia is, but the importance of Wikidata, especially the indirect importance of Wikidata, is much bigger than that. Of course, if you're using Wikidata, for example, for a research project, it's very important to mention it, of course, because mentioning the sources is one of the fundamental things of research, scientific research, but also because it enables, for example, the readers of your website platform to know where they have to edit the data if they find something missing or something wrong, imprecise. They should know that the ultimate source of this data is Wikidata, and that if they fix this in Wikidata, it will be fixed in the place where you are reusing Wikidata, and not only in that place, but also in all the other places that are reusing Wikidata as of now, or that will be using Wikidata in the future. So knowing that Wikidata is behind this is very important also for this reason. Wikidata is a Wikibase instance. What does it mean? It means that Wikibase is the software that is used by Wikidata to run. Wikidata is a MediaWiki website as Wikipedia. So MediaWiki is the software that has been developed during 2001. It went live in 2002 to run Wikipedia. But MediaWiki is essentially a software that is used to create textual pages. So it's not designed originally to store structured data. Since Wikidata stores structured data, it was necessary to develop an extension of MediaWiki called Wikibase. In fact, MediaWiki is modular. So there is a core of MediaWiki that does some basic functions, but a lot of what you see also in Wikipedia is done by MediaWiki through extensions. For example, you see MediaWiki, you see in Wikipedia some formulas, mathematical expressions written in LaTeX. MediaWiki itself would not allow this, but there is an extension called math that allows to write LaTeX inside a MediaWiki page. Wikibase is in fact a set of extensions that altogether allow to collect structured data in a MediaWiki website. It was developed for Wikidata, but in fact, both MediaWiki and Wikibase are open source software that can be used also outside the Wikimedia projects, and in fact is used a lot outside Wikimedia projects. So you can also create your Wikibase instance to store structured data outside Wikidata. And how are data structured in general in a Wikibase instance and then specifically in Wikidata? This is the RDF mapping. So this is the mapping that is used to transform what you see when you load an item in Wikidata into the set of triples that are put into the triple store that is behind the Wikidata query service. So if I open this item, for example, this is a Wikidata item that I'm now seeing in Italian, but if you are logged in Wikidata, you can switch easily the interface language. In fact, if I was not logged in, I would not be able to see Wikidata in Italian. I could only see it in English. And now probably the best thing is seeing it in English. So I will switch to English. And now this is the Wikidata item in English. So everything that you see in this Wikidata item, like for example, the statements, can be seen as triples. So for example, a triple is that this item, the Wikidata item, is identified by Q followed by a number. And of course, a bigger number means that the item has been created more recently. Of course, the oldest item is Q1, that in Wikidata is the universe. So this is a relatively recent item. And this is an item about an article of the Paoli Visova. So this is, of course, if we are speaking about this item, the subject of the triples is always this item, so Q and this series of 9 digits. So this entity, this Wikidata item, predicate instance of is of course a Wikidata property, P31, and the object is encyclopedia article. Or this item, the subject is the item, the predicate is title, that is P1476, and in this case, the object is not an item, it is a string of text, Nicolos 21, which is associated to a language that in this case is multiple languages. This means that this string of text, it would be in German, in fact, but it can be considered valid also in all other languages. Or, for example, this item, subject, predicate, publication date, P577, and here the object is a date, the year 1936. So all of these can be conceived as triples, and we are back here. So the item, this is the subject, and then I can go to the predicate and then to the object in 2 ways. So I can go directly through WDT and then I arrive to the object, or I can go through this in this way. You see that here there is a node in between the subject and the object. This is the statement node. The importance of the statement node is that, as you have seen, Wikidata is not just about subject, predicate, and object, but the statement is a complex entity. The statement can have qualifiers and references. And we see them, for example, here. So here we have copyright status, predicate, object is public domain, but then we have 2 qualifiers and 1 reference constituted in this case by only one set of predicate and object. So if we consider this, you understand that in order to arrive to the qualifiers and to the reference, we have to pass through the statement node. So I go to the statement node through this prefix, P, and then from the statement node, I can go to the reference, I can go to the value of the statement, and I can go to the qualifiers. We will see this in the examples. So let's go on with the presentation. How can I query Wikidata? Basically, there are 2 endpoints that you can use to query Wikidata. One is the official one, and then there is another one. The official one is abbreviated WDQS, the Wikidata Query Service, query.wikidata.org. And of course, it has some personalizations in comparison with standard SPARQL that are useful to query Wikidata. Unfortunately, the Wikidata Query Service has been having increasing problems since 2018. That is the moment in which BlazeGraph, the triple store that makes it work, ceased to be maintained. So as of now, BlazeGraph has been unmaintained for nearly 8 years, and we are very happy that it hasn't collapsed yet, which wouldn't have been impossible, but still it has significant problems. So in the next months, we are happy to know that it will be replaced. If you are interested in the details, you can enter this link. But as of now, what you should know is that trying at first to use the Wikidata Query Service is usually the best option, because for the user experience in writing the query, probably it's the best, but often you may see that the query times out. Also, queries that you may think are relatively easy can time out in the Wikidata Query Service, also because in the Wikidata Query Service, if a query takes more than 60 seconds, so if it takes more than a minute, it times out. The QLabor SPARQL engine that has been developed by the University of Freiburg has the advantage that the queries are not limited to 60 seconds, so they can take a few minutes to run and they will not be cut out. So this is one advantage. But the main advantage is that QLabor as a triple store is much more efficient than BlazeGraph. So also queries that, for example, take 20 seconds in the Wikidata Query Service may take just 2 or 3 seconds, for example, in QLabor. So especially if a query times out in the Wikidata Query Service, try it on QLabor. The only caveat is that if your query relies on some of the things that run only in the Wikidata Query Service and not in QLabor, you will need either to adapt the query, like just writing a few things differently, or to just renounce, because in fact, there are some things that work only in the Wikidata Query Service. What we hope and what we are also confident in is that the new Wikidata Query Service using QLabor next year will be able to integrate in QLabor also the things that as of now work only in the Wikidata Query Service. I hope I have been clear. Otherwise, you can also ask in the last part during the questions, the part dedicated to the questions. So let's go to the Polyvisova. Polyvisova is a very, very important encyclopedia regarding the classical antiquity that has been published in German for a lot of decades. it consists of 84 volumes, more than 100,000 articles written by more than 1,000 authors. And it is still a fundamental reference on a lot of topics, especially the small ones on which, in fact, there has not been much research afterwards, but also for the most important topics. It is still a very, very important reference, for example, because it contains a very complete collection of the passages of ancient sources that deal with this topic. So if you want to know which are the ancient sources that mention a certain person, a certain event, a certain institution, Pauli Visova is still a very important place where to go to start collecting material. Of course, especially the articles that have been written in the first years of this enormous endeavor have aged significantly. This is also the reason because of which part of these volumes, part of these 84 volumes, are in fact supplements that add materials to the first articles in order to supplement them with new scholarship. So, for example, there are volumes in the 40s and 50s and so on that add things to articles that have been written in the last years of the 19th century and so on. So in Wikisource, Pauli Visova has been transcribed has been in the process of being transcribed since 2007. And of course, the project is still ongoing. The transcription, of course, is not only important because it makes these articles available also in the sense that you can copy-paste the text of these articles, that you can search the text through control find and so on. It's important also because you can fix some typos, for example, and because you can make these articles hypertext. You can add links inside the articles to other articles and so on, so that navigation between them can be easier. Also, you can put links to the to information about the authors of modern studies. So if the Pauli Visova mentions a study about a person written by a certain philologist, you can have a direct link to discover who this philologist was, and so on. Why the transcription has not been completed yet? First, because Pauli Visova is huge. Second, because legally some of the articles cannot be transcribed yet. And we also have these beautiful images that have been generated recently by one of the volunteers that has been more involved in the last years in this transcription process. This image shows you the current state of the transcription in green, and like also the length that you see, these are just the pages. So longer intervals of a color mean longer intervals of pages. So this faithfully represents also not only the number of the articles, but also their respective lengths. So the articles in green, the intervals of pages in green have been transcribed by a human and revised by another human. The intervals in yellow have been transcribed by one human, but not yet revised by a second human. The intervals in dark red can be transcribed, but no one has yet done this. The intervals in light red or pink cannot be transcribed yet because the articles are not yet in public domain. And the intervals in black, we don't exactly know, in the sense that we still have to create placeholders for them. And in fact, we are doing it, this task during the last months and weeks. So you will see in the very few months that are following, you will see the black intervals completely disappear, and they will become either pink or dark red. And in the future, we hope to gradually have everything become yellow and then green. But this will take a lot of time. In Wikidata, what we do is connecting the articles already transcribed or yet to be transcribed to the Wikidata items for the entities that are described in the articles. So if a Wikidata item for Hyperides, for example, an anticorator exists, you can interlink the Wikidata item for Hyperides and the Wikidata item for the Pauli Vissova article regarding Hyperides. Let's see how it is done. It's very easy. So, for example, we have the Wikidata item for the Pauli Vissova article about Phaedrus, the writer of fables. And you can see we have main subject Phaedrus. So in this way, I can enter the Wikidata item for Phaedrus. And if I go down in this Wikidata item, you will see described by source. And here you see also other, for example, encyclopedias that contain entries regarding Phaedrus and are being transcribed in Wikisource, in other Wikisources. For example, the Russian translation of Lübker's Antiquity Lexicon is, of course, transcribed in Russian Wikisource, and sometimes you can find, for example, the Britannica is transcribed in the English Wikisource, and you see also the Pauli Vissova. So, described by source, Pauli Vissova, and then you have the qualifier statement in subject of, and through the qualifier, you link to the item of the Pauli Vissova article, and here you are back to the item of the Pauli Vissova article, and going down, of course, you reach the Wikisource transcription of the article that is marked as korrigiert, so it has been transcribed but not yet revised by another person. And here you have all the article transcribed, you see some links, you see all the markup, and so on. Of course, everything is collaborative, so you can help in each of these tasks. You can help in the transcription on Wikisource, and you can help in Wikidata to add these reciprocal links between the items of the persons, the institutions, and so on, and the items of the Pauli Vissova articles. So let's go on. My last slide is some examples of queries that you can also then see by yourself, and that we can also discuss in the last part of this seminar, in the questions part. So let's see the first one, and let's comment it. So this is a very, very easy query. You are just looking for an item. So in the select, you put what you want to see in the results. In this case, I want only one column of results, and this column is the variable item. And then in the where clause, that is, of course, in curly brackets, I define what is this variable. So in this case, the variable item is the subject of a triple where the predicate is described by source and the object is Pauli Vissova. Hovering on it, you see also what this property and this item are. So as of now, the items of persons, places, institutions, and so on that are linked to Pauli Vissova are 18,000, nearly 19,000. And of course, as of now, I'm visualizing only their QID that can be a bit difficult to understand. So if I want to see what these things are, I can use a function that is available in the Wikidata query service, but not in QLever. So if you will copy paste what I am about to write into QLever, it will not work because this function is a personalization of the Wikidata query service, but it's not available in QLever as of now. So I can add here below a line with service, and then I am using the autocomplete to write down this line, service Wikibase label, and so on. And here I can put, okay, that's fine. So auto language means the language of the interface, that is English as of now. So I can also simplify, I can just put, for example, English, multilingual, and then German. So it will show English if it is present, and then multilingual, and then German. It's a fallback chain. So if there is no English, it will show multilingual. If it's not multilingual, it will show German. And then, of course, I should add here item label. And if I want, I can also add item description. This, of course, slows down the query a bit because BlazeGraph has to find all these labels and descriptions, but it's still quite fast. So now I know that Q15 is Africa, and specifically Africa is a continent, and then Q38 is Italy, Q44 is beer, and so on and so on. Then, of course, I can restrict. So, for example, I can put that I want only the items about humans. So I add another condition. Item is the subject of the first triple, and then I add a second triple where the predicate is instance of, and the object is human. So now item has to respect two conditions. It should be described by Pellizzari, and it should be, must be, a human. And of course, the results will decrease because I will exclude places, I will exclude institutions, and so on. The results are nearly half, more or less half. So a bit more than half, 9,000 and something results. And then, for example, I can also add a negative clause. I can add that these items should not be, for example, should not be persons that spoke Latin. So how can I do it? If I want to say that they are positively persons that speak Latin, I can add item and then the language spoken. This is because I remember the property, but if I don't remember it, I can use the autocomplete and I write language spoken, and then I select, and I easily find the QID or the PID, and then Latin. This I don't remember, so Latin. These will find the items that are also speakers of Latin, but if I want to exclude them, I put a minus, then curly brackets, and in this way I am excluding a group of items that have among their spoken languages Latin, and in fact you see that the results decrease. But if I want, last query, if I want to cross the results, if I want to also intersect the data about the persons, for example, and the data about the articles of the Pellizzari, for example, I can use this query. Writers described by Pellizzari, and then I can also show the author of the article to see who wrote articles about a certain category of people. So here you have the person is a human, the person has as occupation, P106 is occupation, this is writer, so the person is a writer, and the person is a writer either directly or is a subclass of writer. This means subclass, and the asterisk means recursively, so the person can be a writer, but also a poet is a type of writer, can be a novelist, which is a type of writer, and so on. And then the person is described by Paoli Vissova, as you can see. And here I am on the statement node, and the statement node points to the specific item. So this variable V is the item for the Paoli Vissova article, and the item for the Paoli Vissova article has a statement of author. So if I run this, what I obtain is 4 columns because I have 4 variables, and these 4 variables are the item of the person, the label of the item of the person, the item of the author, and I have an unknown error, let's run it again, the item of the author of the article, and the label of the item of the author of the article. If it will not run in 60 seconds, you will trust me, and we have it. So we have it, and you see, name, item of the person, name of the person, item of the author, name of the author. Why these 2 lines are the same person? Because there are 2 authors. Of course, I could group these 2 authors on the same line, and then the 2 lines will be merged. But by default, if here there are 2 different lines, this one gets duplicated. This is by default. So here there are 4 authors. As you can see here, there are 4 authors, and so you see Cicero for 4 times because there are 4 authors. So I'll say that this is enough for me, and I would leave the floor to Monica for the part about LAGL. Thank you.
Okay, so Camillo, thank you. And now I'm going to share my screen. Give me 1 second. Okay, share the entire screen. And then here I am. And so give me a second to hide this. Okay, now I am on the slide, and you should be able to see my slide. And if for every, let's say, problem, please interrupt me. So in this second part, I will talk about a project where we use Wikidata, and we show also Wikidata statements. But first about this project, so the catalog of the linked ancient Greek and Latin project. And here I have a slide with an overview of this project. The project is based here in Leipzig, the linked ancient Greek and Latin. And the focus of the project is to extract from ancient Greek and Latin sources proper names, name entities as are called in computational linguistics. And as you can see from these, let's say, icons, the focus is on personal names, place names, and other entities. And part of the project is also to, or at least the project is creating training data also for extracting these entities from ancient Greek and Latin sources, and currently the main focus is on ancient Greek. And a related part of the project is also to create a catalog based on linguistic annotation. So the first thing is to use name entities as anchors in the text and disambiguate those forms that correspond to author names and word titles or descriptions of the content of ancient works in ancient sources. And you can find more information in the project. But now we move to the catalog. Let's say the catalog of the linked ancient Greek and Latin project. In this case, the goal is, as I said, to extract from ancient sources annotations of those elements that in the sources correspond basically to bibliographic references. And I have an example here. You can see an entry about an author, Herodotus, the historian, and the project is adding, is annotating sources semi-automatically. Now we have Athenaeus of Naucratis, Harpocration, the lexicon of the 10 orators, the Suda, which is almost finished for the annotations. And this is an entry summarizing. So as you can see, we have metadata, and I will comment these metadata later because we are using Wikidata statements. But the idea is to really to extract annotations. As you can see here, I have an example for those forms that in the Suda correspond to the name of Herodotus, together with other, of course, authors. I'm zooming in a bit. So, of course, in this case, you can see in different entries of the Suda inflected forms corresponding to the name of Herodotus, and all these forms are grouped with an identifier. In this case, we have a CTS URN, and we have Sunoikisis sessions on the site architecture for using identifiers for classical literature. And of course, in these sources, we can have other entities corresponding to other names of authors. And in the case of Herodotus, of course, well, we can have, for example, references to his histories, and we have another identifier for his work. So this is just to give an idea. So to really to extract the linguistic forms in ancient sources, corresponding basically to bibliographic references, and extract them and to create a catalog based on these annotations, and sources are progressively added in the project. But now I'm going back to the slide, and of course, as you could see before, the project. So the project is creating these linguistic data and training data for both for name entities, but also for annotating, for identifying references to authors and works in general in the corpus of classical literature. And we have identifiers for these authors, but of course we want also to visualize metadata about these authors and works, like the genre of the authors. Currently the catalog, the label catalog, has about 1,830 authors. So this is, so last week we arrived to this number of authors, and of course we want also to ingest metadata about the genre of these authors, because we have many different authors, possibly the chronology, places connected to these authors. And so the idea was, and still is, to use Wikidata statements for getting these metadata, and also for enriching Wikidata. So the idea is to enrich Wikidata with forms in ancient Greek deriving from these ancient sources, and also enrich Wikidata items with information deriving from ancient sources, and we will see later about that. And then on the other side, also to visualize metadata deriving from Wikidata. Before you could see, so if I go back to the main page of the author Herodotus, we can see that through this interface we have a link also to the actual item in Wikidata about Herodotus, and Camillo before explained the language. So all these triples that we have here, we have of course many statements for an author like Herodotus, deriving these statements from many different resources, not only Wikipedia, but also other, we can remember national, international library systems, and so on. And of course, as for now, in the interface of the catalog, we have a selection of, this is just an experiment, I have to say, to show a few Wikidata statements like the place of birth, the place of death, and possible statements about the occupations as they are defined in Wikidata. And we have these statements. But this is just at the level of let's say the web page, because we can of course collect more data, and I'm going to show that. In order to do that, we have now a property in Wikidata, the LAGL author ID property. You can see here a screenshot, and we also have here the actual page of the property, where we have a description. So this property collects identifiers of ancient Greek and Latin authors from the LAGL catalog, and we have a description here, and I have to thank Camillo because he started this, created this property with various statements, and of course we also have examples, and an important part is also, not only, of course, the URL, because there is a direct link to the catalog, but also in this part, the property constraint, of course, we have here, and we have a regular expression here because, of course, identifiers in the LAGL catalog, they have a specific syntax because we have Greek, Latin authors, also authors belonging to other speaking or writing in other languages, and then there is also a syntax because these identifiers can ingest the numbers from the TLG or from Scuola or from the PHI for various projects. But anyway, I will not talk today about these identifiers, but the idea is to have this property because, for example, if we go back to Herodotus, we have in the section about identifiers, we also have together, for example, with I have to search for it because, sorry. Okay, here it is. We have, for example, under identifiers, we have also now the identifier of the LAGL catalog, and through this I can I have a direct link to the catalog, and progressive, I also want to ingest linguistic forms from the catalog into Wikidata. But about statements, of course, before Camillo showed the use of the Wikidata query service, because the interesting thing is that through this property, of course, we can get really a huge amount of metadata about the authors collected in the catalog. And in this slide, I have 3 examples. The first one is, of course, to look for Wikidata items with the LAGL author ID property, so we can really have all the authors, and then I will show the query. Then there is a second query, as you can see, where we can look for Wikidata items with the LAGL author ID, but also locations. And the interesting aspect here is that we can look for places connected to authors, and I will comment to this. And the third one is about, we'll say work-related properties, and I use this expression because we have many statements in Wikidata about, let's say, the genre of ancient authors, and really there is we have many statements, and the complexity is to combine statements about ancient authors and a universal knowledge base like Wikidata, where of course we can represent information about authors belonging to many different literatures, languages, and also periods. But if we want to see these queries, so the first one is a simple query, and before Camillo commented the use of the query. So if you remember what was said before, in this case, of course, we are looking for Wikidata items with a LAGL author ID. So those items in Wikidata which has an identifier for, so basically this means that we get the complete list of the authors of the LAGL catalog, and every time we add an author, of course, we also add it in Wikidata. And what we get here, we get 3 columns. So we have the QID for the Wikidata item, also the item label, which is useful, of course, for recognizing the author, and then we have the corresponding identifier of the LAGL catalog. And in the slide, I also have a commented, let's say, slide where you can see, so find Wikidata items that have a LAGL author ID, and this P12869 is the Wikidata property for the LAGL author identifier, and then, of course, you get also the Wikidata, the label. Then I have a second query, and in this case, the query, and I hope it's big enough, is more complex in the sense that in this case I want to get Wikidata items with a LAGL author ID. So basically I want the complete list of LAGL authors in Wikidata, but adding location properties. So in this case, we have a research question. So do we have places connected to authors? Yes, of course, because ancient sources connect authors to places. And here we have the complexity, because we have sometimes information about the place of birth of ancient authors, or the place of death, or of intellectual activity. But on the other side, of course, for ancient authors, I mean, we don't have a complete, let's say, register with this kind of information, place of birth or of death. And so this is one of the complexities. But after some work, because we have really many location properties in Wikidata, and as part of this LAGL project, we decided to collect a selection of location properties, and you can see these location properties listed here. So we have the place of birth, the place of death, the country of citizenship, ancestral home, place of burial, residence, location of formation, work location, which of course in terms of the language for philologists, it's a bit, I mean, we don't use this kind of language when referring to ancient authors. But it's true that if you query Wikidata for this kind of information, basically information about places connected to authors are spread to different properties like these ones. And there are cases where we can, for example, have information about the place of birth, death, burial, and also, well, let's say residence in some way, location of formation. For example, for an author like Herodotus, we have five places, but I will show that later. This query, where the idea is to look for Wikidata items with a LAGL author ID and at least one of these properties. This is important. So the idea here is to say, I'm looking for Wikidata items with a LAGL author ID and possibly at least one of these 8 location properties. And the result in this case is a map. So you can produce nice map. So this is the map of the result of this query. You have this map, which is the map visualizing authors, well, currently in the LAGL catalog, but authors who have at least a location property in Wikidata. So this map doesn't show every author of the LAGL catalog because there are Wikidata items corresponding to LAGL authors, but without a location property, because maybe they are still missing. So this is the thing that in Wikidata we still need to add, of course, statements. On the other side, there are authors where we can't have a location property. And I also have for you, of course, here we have commented query in the slide. And of course, the interesting thing is that we get every item, every Wikidata item with a LAGL author ID, at least one of these location properties, and then to generate the map, of course, because each location property should have a value corresponding to a place and possibly with the coordinates. So if we have all these, let's say, things, so the LAGL author ID, then at least one location property, and if this property has a value, which is a place, and if the place in Wikidata has coordinates, we have the map. So this is the result that you could see here. And of course, I can enlarge the map, and then, oops, sorry, I'm a bit, okay, for example, if I try, anyway, I will look, so for a place, I have, of course, the coordinates and then the place and the author. Here you see Soli in Cyprus, and then you have this author. And you should get, okay, in this case, you have the Wikidata item, and you get this because this is an author in the LAGL catalog. But there is a last query, which is here, because our question in the LAGL project is, okay, I want to collect statements about ancient Greek and Latin authors. Let's start with places connected to authors, to create a map, for example, and then also to discuss about these connections. The other question is about the genre of these authors in the catalog, because we have historians, poets, philosophers, and so on. And we're interested in visualizing these statements in a knowledge base like Wikidata. And so in this case, we have another query, and you can see here the query where, again, the idea is to look for Wikidata items with a LAGL author ID and at least one of these statements. In this case, the statements were selected, again, because, of course, we have many statements about, let's say, intellectuals in general in a knowledge base like Wikidata. If we look for statements about the intellectual activity of authors in general, we can really look for many statements. And so we work a bit on a possible selection. And so I have here 4 properties for occupation, field, movement, and genre. And also in this case, you have, sorry, it was this one where we have these 4 properties for property for occupation, field of work, movement, which is like a school, for example, and then genre. And if you look at, this is the result of the query where you have more columns, because of course, again, you have the Wikidata QID for the item, the label in Wikidata, the identifier of the LAGL catalog, and then you can visualize you have other labels for the occupation, the field of work, movement, genre. And if you go on, for example, you can see Adrastus is a philosopher, the field is philosophy, movement, peripatetic school, and you get interesting results. Of course, the thing is that these results are interesting because, of course, you see, and they can change because Wikidata is a living project. And of course, there are statements coming from many different sources. Not only Wikipedia, but many other sources. And okay, as I said before, this is just the visualization of the main entry. For example, in the case of Herodotus, I'm in the main page, and this is experimental. I'm visualizing only the place of birth and death and the occupations. But this is, experimental at the level of web visualization. But we can get through the query more statements. And in fact, let's see, before going to this. So if, for example, and this is an interesting thing that I wanted to show before concluding. So here we have the query with the map, and this is a very useful map. But if you extract, because when you generate a map, you can also download, of course, the results in different formats, as you can see here, but also with the CSV file, then you can generate more resources. For example, I have here a map created then with Python, where I wanted to visualize a bit more, in the sense that this is a visualization of data extracted from Wikidata. And let's see if I can show, sorry, this is, okay, on the screen. 1 second, because I wanted to show. Okay, for example, here, if I can see, for example, if and I hope is big enough. Okay, I will enlarge it. In this case, I can visualize. Sorry, I know that my screen is okay. Again, so for example, in this case, I created a map based on Laglen Wikidata, where I have now the author. So under Halicarnassus, I have various authors of the Lagle catalog. And for example, if I look for my Herodotus, I will see that we have Herodotus in the Lagle catalog, but we have various information about, so Herodotus, of course, this is Halicarnassus is in Wikidata, is the country of citizenship, the place of birth, and the residence. But Herodotus in the map is also in Pella, Turi, Samos, and in general in ancient Greece. And this is interesting because this is something that we also find in ancient sources. So the same author can appear on a map in multiple places, because we know that Herodotus was born in Halicarnassus, but we know that he was active in Turi, then probably died in Pella, then he was also in Samos. So this is a way for, of course, for visualizing different places. And these statements are interesting. Of course, the complexity is to convert information from ancient sources into the language of Wikidata, which is the modern language, and also a knowledge base like Wikidata, where we have, for example, information about contemporary authors. And for contemporary authors, we have precise information about the place of birth, death, if it is the case, and many other places connected to his intellectual activity. But I wanted to show this map because this is a map, the map not in the query service, so we can have a first map in the query service. If we want to expand it, and if you want to create a map with more labels, of course you can do that. And the same is also, and you can see here, for other places. One issue that we have is the fact that, for example, in this case, for this location, if I want to show for Lesbos, this is an example where we have, for example, here for Metimna, we have 1, 2, 3, and 4 let's say items in Wikidata. And here you see that we have different authors that who should be grouped under one place, but they are spread in different places because, of course, this is one, we know we are discussing that in the community. The problem is that when we want to connect an author with a place, we can have various possibilities, because we can have the ancient city, the modern city. A clear example is not only with islands, but also in Athens. This is a clear example where we have, of course, many authors here under Athens. But then the problem is that we have, as you can see, Athens, then we have, this is Athens, which should be modern Athens, but we also have classical Athens, and then of course we can have specific places in Attica, like of course Alopec, and then other places. So this is what we want. The problem is when we have basically different Wikidata items for the same place, which is usually due to the fact that we have items for modern contemporary cities, but for ancient ones. And this is something that we are working on in the community. And finally, also for the genre of authors, we can use data extracted from the query and then create a resource where you have, let's say, like this, where I have, I expanded a bit, I created an HTML file basically, which is accessible through the LAGL catalog, where I have more elements, and here I have the identifiers with the links to the catalog, for example, the link to the Wikidata. Then I can compare the label of an author in the catalog and the Wikidata label, and sometimes there are interesting differences, as you can see. And then for the rest, we have our for field, and we can also filter. In this case, we can filter those columns, and we can also search the entire list. And in the LAGL catalog, these resources are available in the main page, and they are constantly updated because, of course, we are adding new authors, but at the same time, we have more items. So items and statements in Wikidata, they change because, of course, more resources are added, and we can also, let's say, correct statements when we need. For example, if we want to group places to avoid this duplication of places. And to conclude, and I know that our time is running, so, and the last slide is about a wiki project, the LAGL, the wiki project LAGL, which is accessible. We have a page here, so if you're interested in it, you can also join the project. We are a group of people, and the idea is to discuss not just about this project, but there are also other projects. As you can see here, there is a list. So we have classicists working on other authors interested in using Wikidata statements, and also trying to, let's say, agree on a few statements, select statements for, as you can see, work-related properties for humans. So as you can see, we have many other properties for occupation, position, education, etc. Then we have geographic properties for authors, and we have many of them. And so the idea is to try to find a consistent way for creating statements about ancient authors, especially when we have a very generic place connected to an author, and it's difficult for us, well, it was the place of birth or of citizenship. So this is I think, the usual problem. We want to insert information about ancient authors in a universal catalog. And this is a problem of libraries, because in a universal catalog, of course, we have information also about, for example, contemporary authors. And so the Wikidata statements are fundamental, but sometimes they are too much for our authors. And so we have this wiki project for discussing mainly genre, geographic properties, and possibly also chronology, which is another interesting field for discussing the chronology of ancient authors. And we have here a first list of statements about chronology. And I'm done for this part. In the last slides, you have references for. And I'm now, I have to stop sharing. Okay, sorry, and I'm back. And yes, but the readings, you have the readings in in the class outline, where you have papers, specific papers on Wikidata, and for ancient people, and also for classical authors, and then you can find other readings in general for the use of Wikidata. So thank you. I know that I'm a bit late, so yes, I used a few minutes more than scheduled. Thank you.
Thank you so much. This was brilliant. And also this was a great continuation of what we started last week, as a matter of fact, to everybody who was here also last week. You will have definitely recognized this. Before we get into the discussion, which I as always, think will be very interesting. Monica and Camillo, would you like to say a couple of words regarding the exercise before that, or we can do this later if you want? Up to you.
Yeah, we can do that. I think that Camillo is
the exercise is basically writing some queries, one about L'Aigle and one about Polivisova, that should be relatively easy. Also, recycling the queries that are in the slides and readapting them. So nothing too difficult.
No, exactly. And remember that there are guidelines for the Wikidata query service. I mean, if this is the first time you write a query, there are very interesting guidelines, and you can, and I think it's a very interesting exercise, because again, you have to think about your research question always, and then, of course, look for statements in Wikidata.
Knowing what you want and translating it into triples. Yeah.
Yes, exactly. This is a very interesting exercise. Your research, and this is, for example, a L'Aigle author is a Herodotus as the subject, the property has a place of birth, and then the object Halicarnassus, something like that. This is a very simple kind of triple, and then you can generate other complex relations. Yeah.
Thank you for explaining this. And of course, to anybody listening, if you are in the seminar with me, the exercises are compulsory. Yeah, just a small FYI. And I think it's actually a very interesting exercise that everybody should do, and not only the students, but also like even more experienced scholars, because it would be only a very nice thing to help us and think in a more structured way. But yeah, so while we wait for questions and comments, I will as always, abuse my power as chairperson. And I just wanted to, I mean, at the very end, Monica, you said two things that I wanted to ask. So I will just ask you if you want to elaborate a bit more on that. First of all, chronology. That's something so interesting and problematic for anything pre-modern. How do you translate this in Wikidata? I'm just curious, because I mean, this is like the portion of the whole term, to be honest, where I feel more outside of my comfort zone. So it's really a question out of ignorance, and so sorry if it's a bit too naive.
No, it's not naive, and this is one of the reasons why I mean, I'm not yet working on this, because again, so speaking of research questions and chronology, for example, I'm interested in the language of ancient sources, and we know that we have specific ways in ancient sources for expressing chronology, for example, through proper names. This is the first thing, because in Wikidata, and this is the interesting thing, is that we can have both these and then other the chronology expressed with modern conventions. And then, of course, the problem is the ambiguity. And if we want to express, let's say, conflicting chronologies or various, let's say, interpretations of modern scholars. And I think that then Camillo definitely, because he has more experience than me in Wikidata, I think he can answer better than me. But the question about chronology is also about geography and the genre. And again, I have a research question. So the ancient language modern conventions, second. Third, of course, ambiguities, that we have ambiguities in ancient sources, but we also have conflicting chronologies in ancient sources and different interpretations, of course, in modern scholarship. And here we have maybe, and then I think that Camillo can say a bit more about I think about the ways for representing chronology in Wikidata, but the problem I think is because I think we have a sort of ranking. For example, this is a problem I have for places, but I have both places. I can't say if one is, we can prefer one to the other. This is, I think, one of the issues we have. But maybe, Camillo, specifically about chronology, I don't know if you want to add something.
Yeah,
I don't have data to show, but yeah.
Many layers of issues about chronology. Of course, one layer of issues, and probably is the one that has been less investigated, is how to express the dates in the way that ancient sources do, because Wikidata as of now supports dates in 2 calendars that are Julian and Gregorian. There have been requests to add other calendars that have not been yet fulfilled. For example, the Islamic calendar and so on. But ancient calendars are complex also because probably it would be difficult to formalize them. Like, for example, Julian, Gregorian are easy to formalize, probably also the Islamic, although I'm not an expert of chronology, but ancient calendars are very much difficult. So if you choose, because this is going on data type date, which is in fact data type point in time, the other option would be data type item. So basically connecting the person to the item of a time period that you define in an item, and then you connect the person to an item. You can also, for example, connect the person to an item that is year XY in calendar Z, if you think that is useful, but okay. And then, this is a kind of issues. Another kind of issues is that, in general, Wikidata, having a data type point in time that is expressed in the XSD format, is not very much comfortable in expressing an interval of dates. So if you have to express that the person died between day 1 and day 15 of the month, that's an issue in the sense that the data type of the value of the statement is point in time. So, for example, you can put as value of the statement the month, and then you can express with 2 qualifiers that are the earliest date and the latest date, the 2 extremes, and then you can query for items that have as in between the 2 qualifiers, that have a date that falls in between the 2 qualifiers. But of course, if some items have just a point in time, so it's expressed just with the value of the statement without the 2 qualifiers, and others require to use the 2 qualifiers because the value is an interval and not a point in time, basically you have the difficulty of either writing 2 queries or having just one very complex query that accounts for the cases in which the value is just the value, and the cases in which the value is in fact the value plus the 2 qualifiers, and the 2 qualifiers are the main, in fact, should be the main focus in that case. And then, of course, another issue is the properties that you use, because basically there are 5 fundamental properties: birth date, death date, florid. Florid is just if the person is attested in one date, and if there are a couple of dates, you have start of activity period and end of activity period. So these are 5 properties, and you should also remember that the dates can be scattered among these 5. A person probably will never have these 5. Sometimes it has, for example, the 2 birth, death, and start of activity, end of activity. If it has these properties, floor width is not useful, in fact, but otherwise it can have only floor width, and or it can have, for example, sometimes you find birth date and death date and the floor width with the century. That is something that would not be done for modern authors, because in modern authors what you say is that if you have the death, putting the floor width is useless. But in ancient authors, sometimes you have the precise year of birth, the precise year of death, and then you put in floor width the century. And this is somehow a deformity that probably we should address at some point, and so on. So there are many complexities in the properties that you use, in what these properties allow you to do, and also, of course, in expressing the things in the way modern sources think and in the way ancient sources think. So there are a lot of layers of issues. Some of them have been more discussed and investigated, and some of them not so much, or nearly no. Nearly not.
Of course. Thank you, Camillo. Yes, of course. And that's it for our authors. The ambiguity is a problem. And then, of course, we could also add, if we use chronologies, if we want to use for Greek history the names of archons or ephors or kings, etc., emperors, of course, I think it's possible. So technically, we can add statements for items about these people in Wikidata, and then we can add the fact that they date the year, like an Athenian archon dating also specific year is possible, and then through this we can get in some way ancient ways. But of course, and then the problem is with conflicting dates, overlapping dates, because we have a ranking, if I'm not wrong. Yes,
I can also say something on this. So basically in Wikidata is very flexible in every aspect, mostly. Wikibase in general is very flexible. And Wikibase also has no problem in allowing conflicting dates, or also in general, like adding multiple values for things that in a human life should be just one. So a person in the real world, of course, the Wikidata also describes literary person and so on, but person in the real world has one date of birth and place of birth, one date of death and place of death. Wikidata allows to put multiple values, and it has no problem with this. But of course, if you add multiple values and without any kind of differentiation, in particular differentiation in ranking, Wikidata has an issue, because if you make any kind of query, for example, to list all the birthplaces or the birth dates of persons, the person with 2 birth dates not ranked one before the other will appear twice. So the person will effectively be listed there as having 2 birth dates. So in order to avoid this, and in general for birth date, birthplace, death date, death place, you can express multiple values, but one of them should be ranked above the other. So should have preferred rank, and the others can have normal rank. This means that in normal, let's say normal queries, the queries using WDT, the prefix WDT, the prefix WDT only takes the things that have preferred rank, if there is a preferred rank, or otherwise it fallbacks into normal rank. So queries with WDT, that are the great majority of queries, would ignore values that are not have the best rank, and so it would avoid this issue of having the person listed twice. But you can phrase the query differently, in a way that ignores ranks. Maybe it shows the rank, but it doesn't exclude the things that have a lower rank. And so you can write the query in a way that extracts everything without losing the things that have a lower rank. So the way in which Wikidata solves this is that you can have everything, but in order to avoid this duplication, and also because in the real world the value has been 1, although you can be uncertain on which, you have to express a preference, but in the queries you can nevertheless find everything without a filter, a rigid filter on the rank. So
this is, of course, a limit, because sometimes, for example, I can't rank not specifically for chronology, but for places we know in ancient sources. Well, he came from Athens or Alexandria.
Like, this is an issue on how you express came, because if you express came on birth date, of course, birthplace is limited to 1 in the real world, and so in birthplace you have to express a reference. But if you use another property, like, for example, the jolly, that is significant place. Significant place is like the generic relationship between the person and the place, that then you can qualify saying, okay, the relationship is this kind, this kind, this kind. This property is not limited. So this property, like, a person can be related to multiple places.
Yeah.
And so there, of course, it wouldn't make sense to express a preferred rank and so on. So it also depends on the property that you use. Birthplace, yes, birthplace requires some kind of, like, of preference on the basis, for example, of the most relevant modern source that wants you to choose that.
And I know that we are late and there is a question, but just to conclude, all these things are very interesting as an exercise for us humanists and classicists, because what you said is important. This is the constant problem, and we should always do that, to express our data in a universal knowledge base or in a library. Because, of course, we say, but we have specific problems because ancient authors, we don't have enough information, but we should always try to understand in this way. So to represent also our data is in a knowledge base, which is useful. And what said Camillo is important. Okay, the place of birth, okay, I don't know, we have 2 places because ancient sources say that, but they don't say that. So they say that, but we should use the proper statement, the property in a significant place where we don't have the ranking. So this makes sense. I mean, of course, at the beginning is not very comfortable for us, because we think in a different way, especially in traditional scholarship. But this is always a good exercise to express in a proper way, respecting characteristics of a knowledge base like Wikidata and, in general, RDF and the semantic web. So anyway, but
also Wikidata will allow you to, yes, for example, take all the places of birth according to a certain source. So you can also filter by the source that supports the value. So this also can be done in the queries. It's a bit complex, so we haven't shown it, but it can be done. You can filter all the values that have a certain source, or also that don't have a certain source. So every kind of filter can be done on what you add in Wikidata.
And I think that, yes, building on this, as a matter of fact, we have a comment and a question that I will now throw on the screen. It's still about chronology, and I think it's for both of you. So whoever can go ahead and read it. And there's a sequitur. I will. So if you could comment a bit on the.
Basically, yeah, maybe what I would say is that we also have like the fact that in Wikidata there is both, for example, date of birth, date of death, and florid on the same authors, like ancient authors, but sometimes also Byzantine authors, for example, is due to the fact that, for example, some sources like TLG, also when the precise dates are known, they express nevertheless only the century. So, like, according to the sources that you use, some sources may use effectively the date of birth, date of death, and other sources that are relevant and authoritative may express the florid. And so, in order not to lose it, you can also add the florid, also if it is somehow redundant in comparison with having already birth date and birthplace. And also another possible aspect that supports the fact of having also florid is that it is somehow easier to maybe find authors that have a florid in that century in comparison with finding authors whose birth date falls, like whose interval of birth date and death date falls into that period, because sometimes, for example, the birth date is uncertain, there is no death date. So also having a florid to a century can be useful, but of course it's also something that needs a lot to be standardized. So a thing that I wanted to say is that a lot of the also the inconsistencies that are in Wikidata are due to the fact that one item uses a certain source and another item uses another source. So if we had, for example, a source used in a systematic way in a corpus of items, these would already make things much clearer and much more uniform, and a lot of the deformity that we see in items is due to the fact that using different sources, also different sources might express things in slightly different ways. For example, some using birth and death and some using florid. And so use of different sources is one of the reasons of these inconsistencies.
Yeah, and also I think, I mean, my feeling would be, so sorry, I'm not, the question was not to me, but I mean, I would think as a user, also in terms of, it's a discipline, the tradition of the discipline. So we talk about, I don't know, the author from the 10th century, and sometimes I mean, you have to dig deep inside yourself and your knowledge to want to remember when this author was born and died. So also in the let's say in the everyday communication, if I can put it like that, or for example, once one person or one student might want to query, I don't know, all authors writing in Greek from the 10th century. And in that case, of course, it makes the query easier to just, let's say, filter by florid rather than by birth and death date, because precisely what you said, so the birth and death date might fall into two different intervals, let's say.
The issue is that if not all the items have florid, if you filter on florid without taking this into account, you will lose a lot of relevant results. And this is the issue of deformity. So if you have the same thing expressed, in this case, it's not exactly the same thing, but if you have in the same field of information, some items using a method of expressing it and some others using a different methods, the risk is always, especially if you don't remember this difference, that you query on one method and you lose all the other items that would be relevant but just don't have that property. And so this is something to be always like taken into account, and probably the best solution would be uniform, like intervening in the items and making them uniform, because intervening on the query, of course, is somehow a patch, but the best option would be having a uniform knowledge base so that you can query in a uniform way. But this is something that requires going and editing the items and making them uniform. And this requires before having agreed on how to make them uniform. So
exactly, which is a whole other conversation. So and we also have a thank you from our user, our student. And so as every session this term, we are beyond our time, so I would say that we thank again Monica and Camillo. Thank you so much. This was brilliant. And just a very short housekeeping remark. Next week there will be no lesson, because in the calendar of both Köln and Leipzig there's no lesson, and we will see you next time. And so thank you again to everybody who came live. Thank you, Monica and Camillo, and bye-bye.
Ciao. Bye-bye. Thank you.